3 of the Google Sheet Training course. In this module, we'll be looking at the various functions available in Sheet and how to make use of them. We will start with Lesson 9, where we will lay some groundworks for the other lessons by looking at the basics of Sheet functions. The various functions in Sheets have been grouped according to their use. Lesson 10 deals with logical functions. In Lesson 11, we will take a look at math functions, followed by lookup and reference functions in Lesson 12. Statistical functions come next in Lesson 13, then text functions in Lesson 14, date and time functions in Lesson 15, and finally, formula mix and match in Lesson 16. There's a lot to cover in this module, so do not be overwhelmed. Go through the module at your own pace, and remember, practice makes perfect. Let's dive right into the first lesson. A function is a predefined formula that performs calculation using specific values in a particular order. In other words, it's a piece of code that performs a predefined calculation. Although the term functions and formulas are used interchangeably, technically they are a little different. A formula is an expression that you type out manually to evaluate some values. Think of it as you are typing out an equation to perform a calculation. A function, on the other hand, is a prepackaged expression that replaces a lengthy formula you would have typed with a name and takes the terms of the expression as argument. As a result, you must call a function's name in order to use it. To use functions correctly, you will need to understand the different parts of a function, how to create arguments to calculate values, and how to properly use cell references. Google Sheet has common functions that can be used quickly to find the sum, average, count, maximum, and minimum value of a range of cells. Let's take a closer look at functions and formulas. Every function must follow a specific order called syntax. The basic syntax for all functions is the same. Only the function name and arguments change, depending on the function. Both formulas and functions always start with an equal sign, but the difference comes after that. For a formula, you type out the expression after the equal sign. This usually involves the use of operators, especially arithmetic operators. Operators will be discussed in the upcoming slides. For a function, the equal sign is followed by the function name, and then the arguments for the function are enclosed in parentheses and separated by commas. Arguments contain information you want the formula to calculate, such as cell references, and/or the conditions that will guide the calculation, such as a logical expression. Multiple arguments are separated by commas. Some arguments are compulsory and some are optional. Optional arguments are usually put in square brackets. For example, the function shown here will calculate the sum of values in the cell range B2 to B8. This function contains only one argument. Multiple arguments, as mentioned earlier, must be separated by a comma. The function shown here, which contains 3 arguments, will find the average of values of cells C2 to C8, B2 to B4, and D2. When you press enter after typing the formula or function, the results of the evaluation are displayed in the cell. But when you select it, the formula will be displayed in the formula bar. To be able to use functions effectively, it is necessary to understand operators. Operators specify the type of calculation that you want to perform on elements in a formula, such as addition, subtraction, multiplication, or division. There are 4 types of operators: arithmetic operators, comparison operators, concatenation operators, and reference operators. We will take a look at the types of operators individually. We will begin with arithmetic operators. As the name suggests, these are used to perform arithmetic calculations, such as addition, subtraction, multiplication, and division. As a result, their evaluation always yield numbers. These operators are the most commonly used of the operators. In sheet, the plus sign is used for addition, the hyphen or minus sign for subtraction, or to indicate a negative value, the asterisk for multiplication, / for division, the percent sign for percentages, and the caret for exponential. Their syntax and examples are shown in the table. Next is the comparison operators. These are used to compare two values and return a logical expression of either true or false. An example of this is to check whether the value of cell A1 is greater than the value of cell B1. The result of this example will return true if the value of cell A1 is greater than the value of cell B1, and will return false if the value of cell A1 is less than the value of cell B1. In sheet, the equal sign is used for equality, the greater than sign for greater than, and the less than sign for less than. For greater than or equal to, we use the greater than sign followed by the equal sign. For less or equal to, we use the less than sign followed by the equal sign. And for not equal to, we use the less than sign followed by the greater than sign. Now to reference operators. The reference operators are used to build Google Sheet formulas and indicate data ranges. The reference operators are the colon, the comma, and space. The colon is a range operator and is used to define a range of cells. It references all cells between and including the first and the last cells mentioned. The comma is a union operator. It merges multiple references into a single reference. This is especially useful for references that are not continuous, that is, references that are separated by a gap. Note, however, that the union operator does not return a true mathematical union, as cells which are included in separate ranges are referenced multiple times. The last type of operator is the text concatenation operator. This is denoted by the ampersand. It joins separate text strings into a single text string. For example, the ampersand sign is used in a formula to combine a text string of Ben and David to return Ben David. Take note that the space is counted as a character, so if the string you are adding doesn't already include spaces, you will have to add them in the formula. The approach is up to you. As can be seen in the example, two ways of achieving this were illustrated. Wildcard characters are used as placeholders for other characters in formulas, mostly to facilitate partial matching. This could be a single character or multiple characters. There are 3 wildcard characters you can use with certain Google Sheets functions. They are question mark, asterisk, and tilde. The question mark is used in place of any single character. The asterisk, on the other hand, takes the place of any number of characters. Unlike the previous 2, the tilde doesn't take the place of characters. Rather, it is used together with the other 2 to show their normal characters, since sometimes you may want to use asterisk or question mark as part of your text and not as wildcards. Let us see how to use these wildcards in functions. We would use sample data on a phone shop inventory. In our example, we want to know how many Samsung Galaxy S mobile phones are there. For reference, the models available are A50, S7, S10, and S20. We would use the SUMIF function for this illustration. Do not worry too much about the function used for now. It will be covered in the upcoming lesson. We will use the question mark to find the number of S7 modules in stock. The formula used is as shown. The function will look for mobile phone models that have only one character after the letter S, which is S7 in this case, and sum the values in the corresponding quantity column, giving a total of 34. Next, we will use asterisks in the formula as shown to look for mobile phone models that have any number of characters after the letter S, in this case S7, S10, and S20, and sum the values in the corresponding quantity column, giving a total of 64. Now let's see what happens when we have some unidentified Galaxy S models labeled S question mark. In this case, we would insert a tilde before adding the question mark in our formula as shown. Using just the question mark will mean including S7 models. As can be seen, adding the tilde gives 36 and omitting it gives 70. We will demonstrate how to create a formula using a simple formula and cell references that adds up the values of two cells. We begin by selecting the cell that will display the calculated value. Then we start our formula by typing equal sign. Next, we select the first cell we want to reference. We could have typed in the cell the address manually. A dotted border will appear around the cell being referenced. We continue by typing the operator we want to use, and in this case, the plus sign. And finally, we select the second cell we want to reference. Now that we are done with our formula, we press enter to commit, and the result of the calculation is displayed in the cell. Sometimes you may want to modify an existing formula. In the example we used for this illustration, we typed an incorrect cell address in our formula, and we need to correct it. To do so, we double-click the cell containing the formula we want to edit, and the formula will be displayed in the cell. We go ahead and make the desired edits to the formula. In our example, we replace C4 with C3. We then press enter to commit. The formula recalculates and the new value is displayed in the cell. A cell reference refers to the value of different cell or cell range on a current worksheet or a different worksheet within the spreadsheet. A cell reference can be used as a variable in a formula. The simplest cell reference appears as a mention of a referred cell after the equal sign. For example, a formula shown here refers to the value within cell C5. This means that the value of the current cell is equal to the value of C5. There are two types of cell references: relative and absolute. Relative and absolute references behave differently when copied and filled to other cells. Relative references changes when a formula is copied to another cell. Absolute reference, on the other hand, remain constant no matter where they are copied to. By default, all cell references are relative references. When copied across multiple cells, they change based on their relative positions of rows and columns. For example, if you copy the formula equal to A1 plus B1 from row 1 to row 2, the formula will become equal to A2 plus B2. Relative references are especially convenient whenever you need to repeat the same calculation across multiple rows or columns. There may be times when you do not want a cell reference to change when copying or filling cells. You can use the absolute reference to keep a row or column constant in the formula. An absolute reference is made in the formula by the addition of $sign. It should precede the column reference, the row reference, or both, depending on which you want to maintain. To use relative referencing, first select the cell that contains the formula. In our example, that will be D2. Now enter the formula to calculate the desired value. In our example, we will type equal to B2 multiplied by C2. Let's now look at how to use absolute referencing. Begin again by selecting the cell that will contain the formula. In our example, that will be D3. Enter the formula to calculate the desired value. In our example, we will type this. The $sign before the E and 1 makes E1 an absolute reference. Press enter to commit and display the result. Copy the contents of the cell you just created the formula in by clicking and dragging the fill handle over the cells you want to fill. In our example, we will select cell D3 to D5. When you release the mouse, the formula will be copied to the selected cells with an absolute reference to E1